So in this video, I am going to go over the touch command and explaining all the flags that come with it. So what is the touch command? It's a command that creates an empty file and can also update timestamps of existing files. So this is the current directory I'm working with. And let's say that I wanted to create an empty file. So all I have to do is just type touch and then the name of the text file, and that creates a text file in the current directory, an empty text file. So there's nothing in it if I use the cat command. Throughout this video, I'm going to use this stat command so that you could see the timestamps of the file. So there's multiple different timestamps here. We've got the access timestamp, a modify timestamp, change, and then birth. So when the file was created. But I want to quickly show you that the touch command does indeed update the timestamp. So if we use the touch command again on hello.txt, and then we use the stat command, you'll notice that the timestamps have updated. Well, the birth of the file stays the same, the birth timestamp stays the same, but the other timestamps all update. It updates to the current time, 1437, as opposed to the previous order time. So to update both, as we just saw, all we need to do is use the touch command like normal, and then use stat, and you'll see that it updates both the timestamps. But if you just wanted to update the access time, all you have to do is include this -a flag, which means access, and then give the file name, and you see that the access time updates compared to the previous timestamp, but the modification timestamp stays exactly the same. And you could do the same thing vice versa. So you could use touch-m, which only updates the modification time now. So if you do stat now, you'll see that the access time stays the same compared to previously, but the modification time updates to a newer time. You could use the --time flag. So if you did this and then you passed something like access, that will update the access time. Same with modify. You could just type modify like this, and that'll just update the modification time. And all the options are kind of listed in the help page. So if you do touch --help, you'll see that you could use the words access, a time, or use, and that's equivalent to -a, and then modify or m time is equivalent to -m. So before moving on with this, I want to talk about the timestamps, because I believe that understanding these timestamps will help us later in the video. So we saw that the file had a few timestamps. The first one was the access time, and this is the last time the file was read or executed. We also saw there was a modification time, and this is the last time since the file contents were changed. And finally, we saw a change time, and this was the last time the file contents or metadata was changed. And part of the metadata could be things like permissions and timestamps. So when we use the touch command, it may update the a time and m time depending on how we use it. And if it does update these timestamps, then it will indirectly update the c time, because remember if you look above the change time, one of the things for change time is the timestamps. That's something it looks out for. So why does it update the modification time? That's a question which first came to mind when I was looking into this, because Updating the access time makes sense, right? Because to touch a file, the system must first access the file's metadata to check for its existence. But it doesn't modify the file contents. So why does it update the modification time? And from what I've seen, it seems like it's just a design choice. Here's just a quote from IBM I saw from their website. So there's a few use cases for why we would want this. So number one is that it's good for triggering build systems. So build tools like make will check the modification time to determine what needs to be recompiled. Another use case would be restarting processes. So a development server may monitor config files, and if the modification time updates, it will update accordingly. And then finally, we've got this backup and sync use case. So some tools may automatically backup or sync by checking the modification time. And we could trick these tools by using the touch command to force them to back up or sync again. I'm going to go over the backup example because I just want to give a practical scenario about how this could be useful. To do this example, we first need to create a backup directory. Let's do that first. So now we've got the text file and then this empty directory called backup. And to do the backup or sync, we'll use the rsync command. And we'll also pass it the archive flag, which means to preserve as much data as possible. So not just the file contents, but also as much of the metadata as possible as well. This will preserve the modification time, but currently it doesn't preserve things like the access time at the moment. And you'll see that when we use the stat command later on. And then we'll just pass it the v flag to see what's going on behind the scenes when we use this command. And then we just pass it the file we want to sync with. So that's going to be hello.txt. And then the location we want to sync the file to. This is going to be the backup directory. And then we want to see the timestamps now of the original file, so hello.txt. But we also want to see the timestamp of the backup file as well. See that. Here's the timestamps. You'll notice a few things here. Number one is that the modification time stays exactly the same on both files. And again, that's because of this -a flag, we're preserving the modification time. But the other timestamps don't stay the same. And this is because during rsync, what we're doing essentially is just copying over this hello.txt file to this backup directory. So we're copying over a new file in a way. That's why the birth time is later, it's the current time. And that in turn changes the access time, and then the access time in turn changes the change time. And again, it doesn't update the modification time because that's the thing that's being preserved from this -a flag. We use the touch command now. So if we do touch hello.txt on the original file, that will trigger rsync if we do use the rsync command. That's going to trigger this. And we could clearly see this when we use the stat command again. You'll notice that the modification time updates as compared to previously. So it updates to the new modification time from the original hello.txt file. And because the rsync got triggered, it means that it copies over the hello.txt file again. That gives a new birth to the file, which in turn updates the access and change time. Finally, I want to show what happens when we update the access time, but not the modification time. That's not going to trigger the rsync. If we did something like touch -a, so it only changed the access time, and then we decide to do rsync. We decide to do rsync now. That didn't actually perform a sync. If we use the stat command, you'll see that the birth didn't change, which means that the new file didn't get copied over. That's because the modification time didn't change. It stayed the same. So rsync was like, okay, the modification time didn't change, so I'm not going to do anything. And you could also see that the access time changed from the -a flag. So yeah, that's just an example of where the touch command updating the modification time might be useful. So another flag you could use is the -c flag, which prevents new files from being created. All you have to do is this basically, so touch -c, and let's say we just created a file that, let's say we wrote a file name that didn't exist, something like that, and we do ls, you see that that file didn't get created. You could also use custom date and times instead of using the current time. To do that, we'll use the -d flag. First of all, I'm just going to show you the current timestamps of the file. And then we could do something like touch -d. And one thing to keep in mind here is that the argument needs to be in string format. So just remember to put quotes around it. And then we could just give a custom time like this, for example, you know, the year 2000, July the 1st, and then we'll just give this time. And then we want to apply this to hello.txt. And now if you use the stat command on it, you'll see that the access and modification time changed to this new timestamp, which is 2000, blah, blah, blah. And one thing I just want to point is that the change time didn't match this custom access and modification time. Instead, it updated to the actual current time right now. This is another way you could write this command. It's a longer way. You'd use --date and then just remember to include this equals sign too. There are also so many different formats you could give. So for example, you can have something like this. Instead of actually giving this format, you could just say next Tuesday. That will update the timestamp to next Tuesday. I do that, and then I use the stat command, and you'll see that it's set to next Tuesday for my current time. And you could also give abbreviations. So instead of putting the full Tuesday, you could just say Q. That will also work. Finally, here's a more complex example. I set the time zone to Europe, London, and then just gave the rest of the time here. And that's a valid argument as well. There's so many different date formats you could give, and I recommend looking at the man page to find out the other possible formats you could give. Another way you could give custom times is by using the -t flag, and that's special in a way because you could give a more compact time. So this is the compact format. You give the century, then the year, then the month, date, and so on. Here's the example I'm going to give. You could do touch-t, and I put 1980, and then I said December 25th, 9 AM, and then 10 seconds. And if I do that and then use the stat command, you'll see that it updates to that time. And this -t flag is special because you can't give this sort of format for the date flag. You'll see that it's an invalid date format. So if you want to use something as compact like this, you need to pass the -t flag. Another option we could give is the F flag or the force flag. But this flag has no functionality, or in other words, it's ignored or does nothing. And it's only there for compatibility with older systems. but you may be interested into what the force command was doing in the older systems. And I'll put a link in the description of the YouTube video which explains it. But to summarize, when a file was set to read only, the force flag was needed to apply the touch command onto it. But nowadays you could just apply the touch command on read-only files without the force flag needed. But you need to make sure that you're the owner of that file, or if you're not the owner, then you use sudo instead. So I want to demonstrate what I just mentioned about using the touch command on read-only files. So first we need to make a read-only file. So to do that, we'll make a new file called read.txt, and then we need to make it read-only. And to do that, we'll use this command and then just put the code 444 in, and that just basically means it'll be read-only for all user types. And you just put the file you want to make read-only. And then for comparison, we'll make the hello.txt file read and write compatible for all user types. So we have to use the code 666 instead. Like that. And then, yeah, the touch command will work as normal for both files. So it works for this, and it will also work for this one too. So as I mentioned before, the touch command only works if you're the owner of the file or you use sudo. So let's see what happens if we switch to a different user. So right now, I'm a user called guest. And to switch to a new user, I'll just use this command, so switch user, and then the name of the user I want to switch to, which is new. And then yeah, I'm switched to it if I just do who am I. And then I need to cd into the directory I was working with when I was the guest user. So I'll do that. And now I'm in the directory I was just working in. So if I do ls, you'll see the two files we were just working with. But now if we do touch on the read.txt file, it's going to throw an error because this file was read only. And this user was not the creator of this read.txt file. But the touch command will work on the hello.txt file because it's not a read-only file. And then as I mentioned before, if we use sudo read.txt, sudo touch read.txt, it will work. The other flag we've got is the -h flag, and that's used when we're working with symlink files. Symlink files are files which point to another file. In general, any changes made on the symlink will directly be done on the target file itself. But there's exceptions to this, which we'll see with the -h flag. So to create a symlink, we need to use this command. So ln-s, and then the target file, which we'll call hello.txt, and then the symlink file. So we'll say something like sim.hello.txt. This file here, any changes we make to it is pointing to this file, hello.txt. And then let's just, for reference, look at the timestamps of these files before we do anything. So these are the timestamps we're working with. And then let's say we do a touch on the symlink file, so something like this. And then we do the stat command again. You'll notice that the original hello.txt file, it's timestamp updates, even though we've done the touch command on the symlink file. And again, that's because any changes made on this file gets directed to the target file it's pointing to. And then the the timestamps of the symlink file itself stays exactly the same as before. And that's because, again, the touch command wasn't happening on the symlink text file itself. It was happening to the file it was pointing to, and it was pointing to the hello.txt file. But as I said, there's a exception to this, and that's when you use the -h flag. So if you want to update the timestamp of the symlink itself and not the target file, then you'll just do something like this. So touch -h, and then you do the normal stuff. Do this. And now if we use the stat command, you'll notice that it's updated now. So the timestamps are on, it's given a more recent time compared to before. And then the target file doesn't change, its timestamp don't change. So yeah, that's basically what the -h flag does. And then the last flag is the -r flag. And that file is used to set the timestamp of a file based on another file's timestamp. So let's just create a new file called touch new.txt. And then again, let's look at both the file's timestamps. So the original file, which was hello.txt, and then the new file we just created as reference. So yeah, we'll use these timestamps as reference. We might want to have new.txt to have the same timestamps as hello.txt. And to do this, we use the following command. So touch -r, and then the timestamps we want. So we want hello.txt's timestamps put onto new.txt. And if we do the stat command again, you'll see that it now has the same timestamps. New.txt has the same timestamps as hello.txt. Yeah, okay, so the access and modify timestamps match the hello.txt timestamp. And then the change time doesn't match this one because the change time is just the time when we actually change the file itself. Same with the birth time, that doesn't get copied over because the birth of the file is when the file was created, and these had different creation times. So the only things that get copied over are access and modified timestamp. And the last thing is that we could use a longer version of the command. So we could do something like touch --reference instead of using -r. So something like this. And that works exactly the same way as the previous command we used.